Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at IP vulnerabilities and threats. We'll be discussing IPv4 and IPv6, ICMP attacks, amplification and reflection attacks, and then finally we'll look at an address spoofing attack. This episode is part of my series on enterprise networking, security, and automation. I'm Kevin here at KevTechify. Let's get this adventure started. Let's get in the mindset of the threat actor. And when we talk about IP, we're going to talk about IPv4 and IPv6. Okay, IP, Internet Protocol, does not validate whether the source IP address that is seen in a packet is the actual source or a spoofed IP address. Because of this, our threat actors, they can send a spoofed source address in their IP packets. They can put whatever source they want in that message. And security analysts, they have to understand the different fields in both IP version 4 and IP version 6 headers. Let's take a deeper look at IPv4 and IPv6 attacks. First, we're going to talk about ICMP attacks. We're going to cover this in more detail in just a little bit, but a threat actor is going to use our ICMP messages, our echo packets, and the pings themselves to discover subnets and hosts on a network. They can also use ICMP attacks to generate denial of service flood attacks, and they can even use it to alter host routing tables. With amplification and reflection attacks, our threat actors are going to prevent legitimate users from gaining access or even use network services by using denial of service and distributed denial of service attacks. With spoofing attacks, the threat actor can spoof source addresses, and we can see this with blind spoofing or non-blind spoofing. To add more insult to injury, the attacker could be part of a man-in-the-middle attack. They would position themselves directly between the source and the destination to monitor, capture, and control any communication that's happening between the source and the destination, and this is done transparently. Either end doesn't know that there's a man-in-the-middle attack happening. And with session hijacking, a threat actor can try to gain access to a physical network and then use a man-in-the-middle attack to not only watch, but hijack a session to become part of that conversation. So let's dive a little bit deeper into ICMP attacks. Threat actors are going to use ICMP for recon and scanning attacks. This is commonly used for gathering information to map out a network topology, want to discover which hosts are actually active and reachable, can even identify the host operating system, and this is known as fingerprinting, and even see what service pack has been used. And ICMP can even determine the state of a firewall, what can be reached through a firewall. Now, threat actors don't use ICMP for discovery, they can actually use it for denial of service attacks. So networks should have restrictive ICMP access control lists, ACLs here, filtering on our edge network. We're only letting in certain ICMP. And you should have it throughout your network topology. ICMP attacks by themselves have a variety of different uses. But commonly, it's going to be for host verification and denial of service attacks. And that's usually the ICMP echo request and echo reply, which is the standard messages in a ping message. With ICMP unreachable messages, we can use this to perform network reconnaissance and scanning attacks. You can use a mask reply when you try to map an internal network. With a redirect, we try to lure a targeted device into sending all of its information through a compromised device, creating a man-in-the-middle attack. And with router discovery, we try to inject false route entries into the routing table of the target host. Just imagine the outgoing possibilities of a targeted host having bogus entries inside. And now we like to talk about what is the real use tools. And here's one of them: low orbit ion cannon. This is an older tool, but it's still been useful. And there's several different flavors of it, written in different languages. There's even some advanced implementations of this. And even with tools like low orbit cannon, it allows you to connect your client to an IRC server and to control your low orbit ion cannon, pretty much as installing a volunteer botnet. If you like this episode on IP vulnerabilities and threats, and you get value out of it, and depending upon the platform you're using, please click that like button, give a 5-star rating, leave a comment. Doing this helps support the channel, which in turn lets me bring you more great content. Subscribe to my channel and click that notification bell. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Once again, I'm not endorsing this tool. This is just for learning and educational purposes. Let's jump into amplification and reflection attacks. This is really a combined procedure. Our threat actors are going to use both amplification and reflection to create a denial of a service attack. With amplification, the threat actor is going to use ICMP to forward echo requests to a whole bunch of hosts. And all these messages that are forwarded to all of those hosts, they're going to contain a spoofed source IP address. That spoofed source IP address is going to be the IP address of our victim. We message all of these machines, and once again, it has the spoofed IP address of our victim. And now the reflection is the second half of this attack. All of those hosts reply to that spoofed IP address, that the IP address of our victim. And that source being our poor victim, that spoofed IP address, and it overwhelms that host, and the host just doesn't know what to do, and finally gets overloaded and just can't respond to legitimate traffic. It happens like this. The message goes out. It could be a broadcast, it could be a multicast to a bunch of machines. That message includes the spoofed IP address of the victim's device. And that's the reflection. All of those targeted ICMP echoes goes to the victim. A good example of this is a tool called Smurf6. It's the amplification where our attacker sends that message out to many hosts. So they amplify the message going out, and then those hosts reflect the response all back to a victim. And so that's where the amplification and response is. And Smurf6 is built using Python. And using Python, you can even see here inside of the code microseconds modified with the I, and then the interface victim IP, the multicast network address, we can actually see live Python code being used in a variety of network attacks now. Lastly, we have address spoofing attacks themselves. This is commonly when we can see non-blind and blind spoofing. Blind spoofing is the easiest to talk about. This is where the threat actor cannot see the traffic that is being sent between the host and the target device. And with blind spoofing, we have our threat actor trying to manipulate MAC addresses for their own denial of service attack purposes. And with non-blind spoofing, we actually have a threat actor trying to hijack a session. They're inspecting a reply packet from a targeted victim. They try to determine the state of the firewall and the sequence number being utilized at that moment. And they try to literally take over and become the client using unethical means. Now, what it comes down to is our threat actor here is connected onto port 2 onto a switch. They see the MAC address of the server that's existing on port 1. The switch right now understands that the server resides on port 1. But if a threat actor spoofs the MAC address of the server and pretends to become the server, then communicates to the switch, then the switch will learn that the MAC address associated with the server, AABBCC, is now coming in on port 2, the ingress. And now the switch says, I understand that AABBCC is the server, but now it's coming on port 2. We are now going to map that to port 2. And so whenever I, the switch, must send traffic to the server, I will now, of course, send it out port 2 to the MAC address of AABBCC. So we have our users that can be legitimate. We have our threat actors that can do bad things on your network, all using the same network devices and network infrastructure that our normal everyday traffic runs on. It was my pleasure to provide you with this wonderful episode on IP vulnerabilities and threats. If you like this episode and you got value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. And all of my socials and contact information are on my website, KevTechify.com, and you can get all these episodes in video and podcast form. In the upper right is my playlist for my series on enterprise networking, security, and automation. In the bottom right is a video I picked just for you. Thank you so much for watching this episode in my series of enterprise networking, security, and automation. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.